I've got a problem up here from the homework. This one's for you folks to try. And again, that'll give you a jump start on the homework. It's number 51. Before I have you pause the video and try it, just a couple of reminders. First of all, don't forget your arguments have to be positive. I recommend that you write those inequalities at the beginning of the problem. You do need to have them written down. That is part of showing your work that you have checked for things. Okay. And if you need to use those to reject some potential answers, make sure you do that. Okay. All right. The other thing I want to point out is that I have a 1 here. So I've got a term that isn't a log. So it's not going to be possible unless I rewrite that as a log to get a log equals a log. Okay. I suppose I could write 1 as the log base 6 of 6. That would be possible. But I think it's simplest if I already have a number to just get all the logs on one side and get it as 1 log equals a number. Just to point out, that means you're going to be subtracting this log over. So you're going to need to remember your rule for subtracting logs. Okay? So that's as much as I'm going to say right now. Pause the video, try this problem, and then we'll work through it together. All right, I'm going to follow my own advice and begin by recording that my arguments of log must be positive. So 7x minus 2 has to be strictly positive, and x plus 5 has to be strictly positive. If I solve these for x, this one means that x is going to be bigger than 2/7, and this one means that x is going to be bigger than -5. Almost always, one of them is going to be sufficient. If x is bigger than 2/7, it's also going to be bigger than -5. But I'm going to have to remember when I get potential answers to check that. Okay. Then we said since this was just a number, it made sense to keep that here and subtract over the log base 6 of x plus 5. So then on the left, I've got the log base 6 of 7x minus 2 minus the log base 6 of x plus 5 is equal to 1. Now I'm subtracting logs. That means I'm subtracting exponents. I subtract exponents when I'm dividing. So this corresponds to the 1 log or the 1 exponent for this division problem, 7x minus 2 over x plus 5. That's equal to 1. Now that I have that, I can rewrite that in exponential form. So the exponent I need when 6 is my base to get this fraction, 7x minus 2 over x plus 5 is my result. That exponent is 1. 6 to the first, that would be 6. Excellent. So we have 6 is equal to 7x minus 2 over x plus 5. Now, this is almost like the sort of equation we would have if we had a rational expression and we were trying to see whether it was ever equal to its asymptote. Of course, if this were a rational function, it would have an asymptote at 7, not at 6, but it's the same sort of equation where I've got a rational expression equal to a number. I want to get those x's out of the denominator, so I'm going to multiply both sides by x plus 5. Now in doing that, I'm canceling the x plus 5 out of the denominator. Ordinarily, I would record at this point, x can't be -5. Because I can see that from here, it's no longer clear once it's out of the denominator. I don't need to explicitly write that because I already have. If x is bigger than -5, and it had to be strictly positive because it was the argument of a log, then x isn't -5. So the restriction I have from it being in the denominator is already incorporated into the restrictions I had from the logs. So let's see. I can distribute my 6x plus 30 equals 7x minus 2. Oh, I like this. This is actually just a linear equation. Excellent. I won't even have to factor. Oh, life is good. 30 equals x minus 2. Let's add that 2 over. X is 32. Do I get to keep that answer? Yeah. It's bigger than 2/7, which means it's also bigger than -5. So it satisfies both inequalities. Now, just a reminder, that's the correct answer. If you had all of this work except this and that answer, you're still going to lose a point because that is a necessary part of your work. Now, I do believe you are capable of looking at the original problem and just double checking that this makes the arguments positive. But I am not capable of reading your mind. I can't tell the difference between a student who said, oh, that's an easy calculation, I can do that in my head at the very end, and a student who completely forgot that that was a necessary step. I am not a trusting person. I will treat you as the student who completely forgot that that was a necessary step and dock you the points. So, you've been warned, it's a necessary step. Write it down, okay? And that's an important thing. A lot of times we have expressions that put some restrictions on things, and then we do stuff to manipulate our equation, and those restrictions are no longer obvious. We want to track them as we work through things. We do that when we have stuff in denominators. We now do that when we have stuff inside of logs.